Every day, billions of people use ChatGPT, Claude, Gemini, Perplexity, and thousands of other AI tools. But have you ever wondered how they can answer incredibly complex questions in just a few seconds? Ask the same question to a human, and they might spend minutes, hours, or even years trying to understand it. Sometimes they may never find the complete answer. But AI responds almost instantly and not only gives an answer, it explains the topic in remarkable detail. So what is actually happening behind the scenes? Does AI really think? Does it understand knowledge the way humans do? Or is there an entirely different process that makes all of this possible? To answer these questions, let's start by thinking like the inventors who built modern AI from the ground up. Before we talk about tools, robots, or future AI, we need to think like the people who invent AI. Most people ask, how do I use AI? Inventors ask, how would I build something that can learn? That single change in thinking is the foundation of AI. The goal of AI is not to think like a human. The goal is to build a system that can perform tasks by learning patterns from data and making useful decisions or predictions. Depending on the task, AI might recognize faces, translate languages, recommend videos, drive a car, write text. Different AI systems have different goals, but they all share the same basic idea. Learn patterns, use those patterns on new situations. Imagine you're teaching a child what an apple looks like. You don't explain every scientific detail. Instead, you show, this is an apple. That's it. Eventually, the child notices patterns. Round shape, stem, certain colors, similar texture. Now you show a fruit they've never seen before. The child says, that looks like an apple. They didn't memorize one picture. They learned a pattern. Modern AI works in a broadly similar way. Imagine you're building your own AI assistant. Instead of jumping to programming, think like an inventor. There are 4 major stages. AI cannot learn without examples. Think of data as the AI's experience. Examples: millions of images, books, articles, conversations, videos, audio, scientific papers, code. The quality and diversity of the data matter enormously. If the data is poor, the AI learns poor patterns. This is where learning happens. The AI processes huge numbers of examples and gradually adjusts internal mathematical parameters to improve its predictions. For language models, a common training objective is predicting likely next pieces of text from context. It repeats this process billions of times. Each prediction teaches it something. Over time, prediction improves. Now we stop teaching. Instead, we ask, what happens when the AI sees something new? If performance is poor, back to training. You collect more examples, fix problems, and train it again. This cycle repeats until the AI becomes more accurate. It's like preparing for an exam. You study, take a practice test, see your mistakes, study again, and improve. Imagine you ask a calculator, 2 plus 2 equals? It instantly answers 4. You know the answer is correct, but you don't see the millions of tiny electrical operations happening inside the calculator. AI works in a similar way. You give it an input and it gives you an output. But unlike a calculator, AI makes its decisions using billions of mathematical parameters. That's why it's often difficult to explain. This is known as the black box problem. Building a powerful AI isn't enough. It also needs to be useful, safe, and responsible. That raises important questions. Can it spread harmful misinformation? Could biased training data lead to unfair decisions? Does it protect people's privacy? Can it follow human instructions safely?
So if you can cook me the meal, I'm gonna go out in here and play Fortnite, okay? Yeah.
And what happens if someone deliberately misuses it? These questions don't always have simple answers. There are still active areas of research, engineering, and public policy, where improving one aspect often means making trade-offs in another. This distinction is one of the most important things to understand about AI. AI doesn't memorize facts the way humans do. Instead, it learns statistical patterns from its training data and, in some cases, uses additional information provided during a conversation or through external tools. For example, if millions of recipes pair tomatoes with basil, AI learns that these ingredients frequently appear together. It's likely to recommend basil with tomatoes. Not because it truly understands cooking, but because it has learned that pattern. AI does not directly observe the world in real time unless connected to appropriate tools. It does not have personal experiences or consciousness. When information is incomplete, AI predicts what is most likely based on learned patterns. Sometimes those predictions are correct. Sometimes they are wrong. This is one reason AI can produce convincing but incorrect answers.